So yeah, I started the slide deck. I shared with you before. So basically I started from the beginning, and here it starts all like deep learning, machine learning, and artificial learning, because sometimes I think frequently machine learning and artificial intelligence they use, but which part is which part? So I think it's give the kind of, it's good the like key understanding starting from artificial intelligence, which is in humans, animals, it's applied in machines. And then what's machine learning? It's a subset of AI, which is use statistical methods to enable machines to improve the experience. And then deep learning is also subset of ML, which makes computation of multi-layered neural network feasible. So that's part. And then machine learning, as said, it's subset of AI techniques that allow system to automatically discover representation needed for future detection or classification from raw data.
Hey, so Sako,
Yeah.
you actually brought up an interesting question I have for you.
Yeah.
So would that be more how should I say, more fruitful? Would that be more fruitful for us if we expand the discussion a little bit wider to actually talk about AI instead of just machine learning? Well, what do you think?
Yeah, definitely. As you saw here, artificial intelligence, it's the bigger part, and
Yeah,
we just
yeah,
can talk more also about. So it was in I think it's frequently it's interchangeably used, but yeah, I think we can start more on that part too. But where there is also include the hardware part and continuously, like robots and stuff, robotics.
okay.
Which is, yeah. So.
Because for AI, there will be a lot more interesting problems to solve.
Yeah, I think it's pretty much also for the machine learning part, AWS specific. I think by next week it will be completed, just to go through the algorithm and stuff to complete. So I think we can finalize it by next week and then pick the direction we want to go on.
Okay. Yeah. Yeah. It's only a suggestion. Yeah. Because. Okay.
Yeah, because currently it's also more like it's kind of all of this terminology and stuff getting used to it. And yeah, I think we will know better moving forward which part we would like more invest. So yeah, as we can see in the machine learning, it's for feature detection and classification from the raw data, and it's more about statistical models that machine used to. Because I will just pretty much gonna read it because I just I extracted the part that made sense to me from various sources. And yeah, so machine learning algorithm build mathematical model based on training data to make prediction or decision without being explicitly programmed. Hi, Egeman. So in this case, I think the main thing that in machine learning case, the few key points are we need the training data, which we discussed in previous weeks, the training data, test data and stuff. And without explicit instruction, based on the pattern and inferences, we can execute specific tasks. So the difference from traditional programming way that there is no explicit instruction. So that in that case, we use machine learning. So as we can see, it's automatically discover the features and classification from the raw data. And here is some machine learning terms. I put that once we were going in past weeks, So classification, as we know, it's assigning a category. For example, is it dog or cat? And regression, predict a real value for each item. It's like stock prediction, and we are trying to see how it's gonna be stock price. Ranking, I have seen also, if you remember, like relevance to machine learning topic. There was different topics, and we crawl over the internet and find the relevance to some specific topics of the news. Clustering, partition data into homogeneous regions. I think it's, again, it's more like a grouping of the data, clustering. And based on this, we can, I think we can also say based on the topics clustering, that relevance. And dimensionality reduction, which I think there was example also, like if we want from, if we have table, we have a lot of features that doesn't affect to the end result. We can just get rid of some columns in the table. So from 3D, we can reduce to 2D and stuff. So that's dimensionality reduction. Okay, and features, attribute associated to an item represented as a vector. So for example, if we talk about as object the dog can have the features like the leg, eyes, and ears. All these are the features. And labels, category or real association to an item. I think it's in the end of the day, based on this, we can find labeling if it's for example running, and if it has 4 legs, and then we label it as a dog or cat. And for the data, we already discussed training, test, and validation data. And I think last time we also raised a question about the validation data. So it's labeled as a training data, but it's more for tuning parameters. So, but test data, it's labeled, but we don't see. It means like it's more like to test the final result. But in validation case, we can still see the end result, and then based on this, we can tune. So, okay, and then last one, machine learning terms. We have 3 types of learning: supervised, reinforcement learning, and unsupervised. And supervised one, as we discussed, laid for prediction on unseen points, and for prediction. So, and then unsupervised, we don't have any labels at all, so we don't know either it can be cat or dog. In supervised, we know based on the pictures of cat and dog that it's supervised learning. And reinforcement learning, we have some of them we know, some of them we don't know all the data. So it's basically based on the way it's trying to figure out. Yeah.
So what does it mean by for reinforcement, right? So yeah. Reinforcement, why do we say that we are using unlabeled data? That's the difference between supervised and reinforcement, right?
So yeah, a good example, Professor, in this case would be, for example, there is a robot. Yeah. And there is a basket of dog and cat, and we give the task, pick the dog. And if it's going and picking the dog, which is right, we kind of give the reward. And when we do some rewarding and the robot understands it's good, he did the right thing. So it's kind of this way, it's like teaching the kid. It's the way, like if they pick the right dog from the basket, we say, hey, reward, and it means 1, which means good. And then they go, next time the robot picks cat, we say -1. He understands that it's not the dog. So this way it's keep training.
Oh, yeah. Oh, I see.
So it's like we are helping a bit.
Okay.
During the training data, yeah.
You have a labeled data And the unlabeled data is because you are collecting more. You're collecting the result from your prediction and use that to reinforce your learning. That's why it's called unlabeled.
Yeah, exactly. So there is a loop of learning. It's not only based on the training data.
Okay.
We have some training data, and then it start picking, and then we are doing the loop back, and like as a person helping, or there is some reward ways, so kind of chain, and then we get more and more data, and it's advancing.
Yes. Okay.
And in supervised, we don't have any of this labeled data. It's
okay.
So yeah. Okay, so okay, and deep learning. So deep learning is part of ML.
Yeah.
It's based on artificial neural networks, which feature learning. So I will briefly talk about these two as well. So deep learning has kind of four types. I would say the deep neural network, deep belief network, which is rarely used nowadays, recurrent neural network, and convolutional neural network. So, and I put brief description. Artificial neural network in general, it's something like that. We have the input layer, output layer, and then in the middle there is hidden layer. So interconnected group of nodes. Each node represent an artificial neuron, and a row represent connection from the output of one neuron to input of another. So that's artificial neural network. It's general term.
Yeah.
What's feature learning? And technique that allows system to automatically discover the representative for feature detection or classification from raw data. So in this case, for example, there is input the car, and we don't need to say feature extraction in this case. Like it has, for example, features like it has a wheels, it has a windows. So all this stuff can be done with deep learning. It's like layered full mesh architecture, and based on feature extraction and classification, we will say if it's car or not car. So it's kind of feature learning, but we don't specify what makes car, what are the parts it has. So it's called feature learning. And yeah.
Wait, can you go back?
Yeah.
The last system all discover present needed to feature detection, feature detail from raw data.
So
deep learning also has the model building model and also the regression, right?
So yeah.
So or the, how do you call that, regression, or do you call that classification?
For
it can do the both.
It's like if you come to regression, like in linear regression, we were doing like based on the height of the penguin, find the weight of the penguin. That was, for example, linear regression. So I think, yeah, that applies in both, and then we can find classification if it's a car or not car, and if it's what model of the car. We can, based on, it's called classification part, and then we can predict, in this case, if it's find the height of the car, for example, based on.
Okay.
So that's called coming the prediction part. Yeah. Prediction classification. Yeah. So yeah, I think, yeah, feature learning, and then we are coming to the four parts which we were talking about. What here we mentioned about the deep learning, and we have DNN, DBN, RNN, CNN, and now Gonna go through them. So deep neural networks, it finds the correct mathematical manipulation to turn input into the output, whether it's linear or non-linear. So it's moving layers by layer, calculating the probability of each output. The understand to recognize car types will go over the given image and calculate the probabilities that the car in the image is a certain type. So it's again it's like layered, which we have input hidden and output full mesh node. That's deep neural network. Again, you can also feel free to, from your experience, just if you have any additional comment. Yeah. So
right. It can be applied for both classification and prediction tasks. Basically, finds or tries to find the relationship between the information and the pre-seen result, the information and the label. And all of the nodes, they have some weights. And based on tuning the weights, it finds which part of the information is most relevant with the result. And with having the multiple layers, then it calculates which combination of which parts of information are most important for our label.
Yeah.
But giving the different weights, which can be said as taught as importance, giving the different importance of different parts in our data, and giving different informations for different combinations of parts. It basically tries different features, creates different features from our information. And by changing the weights of that information combinations, it extracts the important features.
Yeah, I think it will be in also the slide in more detail with example what Egemen was saying, if it's doesn't make sense. Yeah. So yeah, it's more like general. Briefly, deep neural network and deep belief network, which is kind of the difference gonna be that there is connection between the layers, but not between units within each layer. So consists of multiple layers with values, whereas there is a relation between layers, but not the values. So the main aim is to help system classify the data into different categories. So it's, again, it's not, it's rarely used nowadays. I didn't find many use cases for this guy. And recurrent neural networks. So it's support processing of sequential data by addition of a loop. So basically, what does it mean? It's not only in one direction. It's like loops, cyclic. It's like not fast forward. It's also backward. Once it learned, it's like when you read once a text as a person, you remember some words, and then you come and when you read again, it's built on top of your memory. So there is kind of memory of it, it's remember, and it's kind of adding on top of it, not starting from scratch. So it's the recurrent neural network, that's the idea applied here. This loop allows the network to step through sequential input data while it's persisting the state of node in hidden layers between the steps. So is it clear, that one, Professor?
No, sorry, this is not very clear to me. So there is a loop in the hidden layer, right?
So yeah, so you kind of apply input you have, and then you do some processing, you get the output, and then based on this you go back and apply again. So it's kind of looping. So it's as the similar example, when we read the text, we only remember some words from the text, let's say, and then we read again, we remember more and more, and it's keeping the memory in the memory. So
I see.
So yeah, it's and then the last one, CNN, which is applied mainly to image, video, and stuff, CNN, and it's also part of the DNN, which is each neuron in one layer is connected to all neurons in the next, so it's fully connected neuron mesh, which is CNN called. So yeah, that's. I made till that part, but I also, yeah, I think I can stop recording here.